Now, this is another buffer solution question, but in this question, it's asking you what the pH of the buffer solution is after we've added a bit of alkali. So remember, buffer solutions resist change in pH when you add anything to it, but acid, alkali, or water. And some questions may ask you to work out the new pH of buffer solutions after adding something like that. What you've got to remember is that for buffer solutions, we're always using this Ka expression, and then when rearranged, like we did in the last question, we get this. So we're always looking for the number of moles of HX, number of moles of X minus, once the reaction has occurred. So in this question, we've got, and I always lay out my answer as weak acid plus base makes salt plus water. And we write out what we have at the start, and then write out what we have at the end. So at the start, the amount of weak acid we have, it says that we have the concentration of ethanoic acid was this, and the concentration of ethanoate ions was this. And it says an amount of sodium hydroxide added to 500 centimetres cubed of this buffer solution. So we need to work out the moles in that 500 centimetres cubed first. That's half a decimetre cubed. So all we've got to do first is work out the ethanoic acid number of moles, which is going to be 0.260 divided by 2, which equals 0.13, and the amount of salt, which is the ethanoate ions, will be 0.121 divided by 2. So 0.121 divided by 2, which gives us 0.0605. Now, when we add base to a buffer solution, that's going to reduce the amount of weak acid in that solution and increase the amount of salt. If we add acid, that's going to decrease the amount of salt and add to the amount of acid. And that's important for you to remember. With a buffer solution question where they're adding extra base or acid, they may add a base or acid that has more than one H plus or H minus ion in it. So the first thing for you to check is the formula of whatever you're adding. So this is NaOH. So you are just adding one OH minus ion per mole of the or 1 mole of OH minus ions per mole of the alkali. So we only have to worry about the fact we're adding 0.007, so 7 times 10 to the minus 3 of base. So we're going to take that away from the acid, and we're going to add it to the salt. So that at the end, we've got 0.13, take away 0.007, which gives us 0.123. And on the other side, we're going to have 0.0605 plus 0.007, and that's going to give us 0.0675. Remember, if this had been something like calcium hydroxide, which is CaOH in brackets 2, then we'd need to multiply this amount of moles of base by 2 first before we take it away from here and add it to here. So you must make sure you check the formula of the acid or base that you're adding. So then we use these numbers and we put them into our expression that we've already worked out. So it's going to be Ka, which we have. Where is the Ka? I can't see it. You must be given it elsewhere in the question. I've deleted some of the question. I do apologise. But the Ka is 1.74 times 10 to the minus 5. Then you'd multiply that by the moles of HX you've just worked out, which is 0.123. Remember, your weak acid is your HX. And divide that by 0.0675. And that will give you 3.171 times 10 to the minus 5. Then you'd work out pH, which was the minus log of the concentration of H+. You plug this number in, and that will give you 4.50.